A clock reaction in chemistry refers to a chemical reaction in which there is observable change over a predicted duration of time. It is usually used to help determine the reaction's kinetics. The iodine clock reaction is a kinetic experiment that explores reaction rates, and a color change of a dark bluish black color is observed when I2 reacts with starch to form a complex.
In the iodide clock reaction, there's two competing reactions. There's a slower rate determining reaction, and the other is a fast rate reaction. Iodide reacts with persulfate to form I2 and sulfate. The I2 is quickly consumed by the second reaction to form iodide. As soon as the thiosulfate is consumed, sufficient I2 can be formed to form a complex with starch. We first obtained 14 clean and dry test tubes. 7 of those test tubes were labeled as A, and the other 7 test tubes were labeled B. As shown in this table, 7 trials were performed with varying amounts of sodium thiosulfate, potassium iodide, and potassium nitrate. These were placed in test tube A, and varying amounts of ammonium persulfate and ammonium sulfate were added to test tube B. The volume of 0.5% starch was consistent throughout all 7 trials.
The contents of test tubes A and B were mixed, and in that instant, the timer was started. As soon as the color change was observed, it indicated that I2 reacted with starch to form a complex. So, the timer was stopped and recorded for future kinetic analysis. It was suspected that there was not enough starch to form the classical, really dark black, bluish iodine reaction color, so we added a bit more starch at the very end to create the color desired. It was observed that the concentration of either potassium iodide or ammonium persulfate had a linear relationship with the reaction rate. As shown in the table, the reaction rate in trial 3 was double that of trial 2, when the concentration of ammonium persulfate was increased. This suggested that each reactant is first order. This was later confirmed in analysis, stating that the rate order of potassium iodide was 0.983 plus or minus 0.236, and the order of ammonium persulfate was 1.009 plus or minus 0.196. Knowing rate constants of the reaction, concentrations of both reactants, and the rate orders, it can be substituted back into the rate law to solve for rate constant. It was determined that the rate constant was 6.51 times 10 to the negative 2 plus or minus 6.48 times 10 to the negative 3, 1 over molarity seconds, at 21.9 degrees Celsius.
Rate orders calculated agree with literature values, but rate constant does not agree with one standard deviation of our calculations. Literature values had a rate constant of 2.89 times 10 to the negative 2, 1 over molarity seconds, whereas we have a rate constant of 6.51 times 10 to the negative 2, plus or minus 6.48 times 10 to the negative 3, 1 over molarity seconds. These results do have the same magnitude, but unfortunately do not agree. Rate constant has an acceptable but high relative standard deviation of 10%. The relative standard deviation of the rate order was 24%, which was unsatisfactory and gave suspicion to rate constant relative standard deviation. As proper error propagation was not able to be completed due to lack of concentration certainty. Future analysis needs to be completed with proper stock solution preparation and volume measurement.